Yeah, it's good to record also the meeting. Some facts about me. My name is Krzystof Wojslaw. I come originally from Poland. However, I live in Norway for last 8 years. And for almost 6 years, I have been working on the Europe's biggest consultant company, Sfeco. I work there as a parametric design specialist. And for those who don't know Sfeco, Sfeco is operating in 14 different European countries and work almost 18,000 of engineers and specialists. So together in Sfeco, we co-create solutions that address urbanization, and we try to capture the power of digitalization. So I would try to show you and prove it in this today's presentation, and of course to make our society more sustainable. So this is our main goals. As Tulika said, I have also a blog and YouTube. If you will ask me 5 years ago if I will be YouTuber or a blogger, I will say no, but things change a little bit. So yeah, I'm active blogger and YouTuber. And for those who haven't seen Beam Corner blog, so I really recommend. We have the whole topic about VDC method. So you can go there and check what is a ICE sessions, what is a metrics in VDC, and what is a PPM. So we can go and read these articles. We are engineers who are writing these articles. So there's a really practical knowledge in the really simple English language. Okay, so to the main topic. So Ranselva Bridge is a 634 meters long cantilever bridge situated 80 kilometers from Oslo. And the BEAM team consisted of 8 people from 5 different countries. So good collaboration here was a key to success. In this short video, you can see the scale of the project and the details. So the bridge has a 7 spans of the variable box height of the freestanding parts, as you can see on the video right now. So the main box, the height of the main box was 14 meters, which corresponds with the 4-floor building. So you can see the scale. And as you can see, the detail was defined really high, like the level of detail. So the aim was to avoid all of the collisions and to model of the pre-stressed cables that is all more than 300 different geometries. So the design and build project, as this one, is a partnership between 4 parties: PNC, the company from Austria, as a contractor, Isaksen from Norway, responsible from groundworks, and Sfeco, together with Armando Rito, as a design team. And Ranselva Bridge was my part of VDC implementation for VDC certification. And this was a main VDC framework. So we have really well-defined client objective. It was bridge opens 1st of March 2022. And that meant to be that it needs to be completed 2 months earlier than the similar projects. We had, of course, some problems with the COVID. However, we still would like to open this bridge at this point. And to make the design and building finish to this time, we have to design project objectives. So here we defined 3 of them, and we work really hard to obtain this project objectives. So first, reduce time for 30-part control, so to make this control smoother and make this design smoother. Second of all, reduce construction time, so we have to use the 3D models like ordering directly from the 3D model. And the third one, reduce designing time, and here we use the parametric design. So for the purpose of this presentation, I have rearranged a little bit this framework, and I put as a BEAM model in the middle of our collaboration. So this was our key to this team integration. So first of all, drawing class project. They become a standard in Norwegian construction industry last years, and today, if you would like to deliver project to the Norwegian authorities, you really have strong arguments to deliver the bridge with traditional drawing. I think it's about 90% of bridges are delivered model as a model based. So in traditional project, let's say we call it in Norway right now as the old days, we always need to create drawings, right? So plan, so cross-section, and so on. Afterwards, we changed a little bit the way we are working, and we have started creating first 3D models, like using Revit, Tekla, and other softwares. So it was a significant step forward, but still we had to transform this 3D object. If you on the screen, you can see this pink box to the 2D drawing. So we have to do like projection from the 3D model to 2D drawings. But if you think about it, it actually doesn't make sense, right? Because it's an extra phase of making drawings where most of the errors occurs. So now we are in the phase when actually the model that we create, we need to, of course, put more information in that. It will be more detail, but we can build directly. So for example, take all the coordinates. We don't have to make all the dimension on the drawing. Actually, we can take all the coordinates directly from the model, which is placed correctly in the world. So the main advantages of this approach of drawing class or model based, you can call it as well as this one, in this way. So first of all, better understanding of the model. So it's easier to solve the problems at the site. So if someone do not understand the problem, they can go inside the model and rotate the model and check the collision, for example, from the different perspectives, how we can solve it. So this results in 50% less calls from construction site to designers, because contractor could solve more problems actually at the site without the help from the designer. And of course, the model was defined as a known collision out of the reinforcement. So 95% of collision was avoided in this case. Moreover, designers skip the time-consuming part of making drawings. So working as a designer, I like it most, because I really hate making the reinforcement drawings. And this is the time that we skip making drawings, we can use to make this 3D model more accurate. For contractor, is a more flexibility. So for example, with ordering materials and reinforcement, because at the site, people prepare all the list by themselves. And the last one, my experience with the cross-border collaboration shows that every country has own standard for making drawings. So in this project, we work together with Sweco in Finland, Poland, Denmark, and Sweden. So in this country, the drawing standard was different. So it was different names, different fonts, and you can just call it what was the differences. However, like 3D models are more standardized. So there is a more standard way how you define the 3D models. Of course, there is some data on laying on the different levels. However, you can clearly see that there is a more standardized than the drawings. And of course, challenges. We haven't. There's 3D models at the site do not solve all the problems. So first of all, we need to spend more time for this 3D modeling, because models need to be more accurate, and we have more information, as I showed you on this model before. And the biggest challenges, in my opinion, that contractor needs to take more responsibility with ordering and taking coordinates. Before, it was designer who has a responsibility to show the contractor all the coordinates. However, now this a little bit changed a little bit. So of course, it needs to be, contractor needs to train the people and invest, of course, in the software and hardware. Okay, so it was the first part, it was drawing class. The second part of the team integration, it was using the collaboration platform. So here, Sweco have developed a web-based project platform on the Autodesk Forge. The platform was named Smart and provides both insights into model and overview over tasks. So here, instead of using emails, we can register all the tasks in the into this software. And the key of this software is web-based. So you don't have to install program on your machine, on your computer, to use this program. So you go, you have the login, and you can register the task. Instead of sending thousands of emails, you can just register the task, the priority, the date that it should be fixed, and the discipline that should fix this problem. And afterwards, in Jira, we can collect this task and make a follow-up of these cases and work tasks that are more structured. So, for example, if someone is on a vacation, so actually we can go into tasks and check what is the status instead of waiting 2 weeks if someone come back from vacation. So next one that is actually my favorite one, the parametric design. This is what I'm doing at my work. So for that complicated geometry as runs ELVA with such level of details that I showed you, the application of parametric design was actually obligatory. We need to remember that we do not have drawings on this project, so 3D model needs to be accurate as possible. So parametric design, for those who haven't heard about this topic, so it's creating algorithm that creates geometry. So our geometry will be connected in kind of with algorithm. So on the right side, you can see the parameters that are defining, for example, column in axis. So every time when you, for example, would like to change the width of the length of the column, you can just go into program and change it. So again, when we come back to our team, how we work. So I was the leader of the parametric design team that you see on the screen. So at this time, we started in 2018. So the average age of this team was 27, and I was who was the leader of this group. I was 28 years old, and actually I was the oldest one. So all the seniors engineers involved in the projects was terrible, like they were scared at the first time when they saw that there's 6 guys, 27 years old, going to work on the one of the biggest projects that we had. But of course, after some time, we convinced them with a good results, and we can work that on this project. And for sure, we are going to work with this team on the next projects. So this team consists of young people that we call visual programmers. So visual programmers are engineers who know their subject. For example, in this case, it was bridge engineers that can design bridges. However, they have like programming skills. And I'm not talking about hardcore coding. However, I'm talking about visual programming, which is easier to learn. And to show you how this parametric design can be used is a video that's showing like principles. So here we have a foundation that we are going to make a steel core piles. The gray surface on this model is a bedrock. So you can see afterwards, when we change the number of piles in this foundation, we change the length of these piles and it will be adjusted. So every time when on the ice session, we could choose the best solution together with the contractor and show to him what is the cost of the changes. So here, another example for the really bad rock where we have concrete piles. So here we have defined reinforcement that is automatically created, and we can change our project and see the results and the costs on the meeting. So this is the way how we are working. So one of the advantage is, of course, the fast changes that we can apply during the meeting. However, another advantage is that we can reuse already scripts on another project. So for example, we are going to project like similar projects in Sweco, like in this scale. So we are going to use a lot of scripts and work already done. So we are not forgetting about this project and starting from scratch. So we can reuse and save time for the next projects. And I mentioned about iSession. And of course, we made iSession like in the VDC framework. However, we done this a little bit differently. So we integrated concurrent engineering.
I can't hear Krzystof. Is it only me or?
I cannot hear him, Krzystof.
Okay.
I think he's working on his sound.
Okay, do you hear me now?
Try
I
again.
can hear you briefly, but can you speak again?
Yes,
Yes,
I think
perfect.
I have a lag. Do you hear me well now?
Yes.
Yes. Okay, so we come back. Sorry for that, some technical issues. So we organize ICE session, but together with hackathons. So as I showed you before, this team, parametric design team, so we invite this team from the cross-border and we sit together in the one room, together with contractor, with the client, and we have also, of course, facilitator on everything. However, we have this hackathon, so the guys and girls sitting together and writing programs. So actually it was the next level of ICE meetings that we can actually make our, write our programs and see the results on the meetings. And the last topic of the integration of the team. So it was important to also show these models that actually we produced to the site. And here we tested Trimble Site Vision. It's a user-friendly augmented reality system that takes 3D model directly from the office to the site. And actually, it's a new technology. It's easy to use, requires little training, and provides incredible good overview of what is going to be built. And afterwards, we get 1 centimeter tolerances. So I think in the future, it can be a good tool for making quality assurance. So checking how the reinforcement is placed or pre-stressed cable. So we can have a better understanding of the scale of the structure and see how this bridge is going to build. So I'm really looking forward to integrating like 3D models at the site. All right, so it was the last topic for today. So thank you very much. If you have any questions, so write in the Q&A or just reach me on the LinkedIn. So I'm more than happy to answer all your questions.
Thank you so much, Krzystof. Unfortunately, we do not have time to take questions right now.